Good morning. We've got Trey Hunner here, and he's going to talk to us about readability. Thank you, Trey.
Thanks, Jim. Hi, so I don't have an introduction slide, so you can look stuff up about me on the internet. Feel free to ask me afterwards. So we are going to talk about readability. Readability is simply the measure of how easily we can read our code. We're talking about code here. This is a definition about text from Wikipedia. It's the same deal. So we are all here because we care about readability, or because you stayed in this room from the last talk. For those of you who care about readability, why do we care about readability? What makes readability important? Every time you fix a bug, change some functionality, or add a feature to your code, you probably need to read your code. So you probably read more code more often than you write it. Also, code doesn't always completely stagnate. You do sometimes need to change code. To change code, you need to read that code. Readability is a prerequisite for maintainability. You can't maintain code unless you can read it. Also, not all teams are immortal. You do sometimes need to hire new developers. When you hire new developers, you need to onboard those new developers. It is a lot easier to onboard a new team member if they can read your code. Before we get started, let's make it clear what we are not talking about. We are not going to talk about how easy it is to write code. We are also not going to talk about how easy it is for a computer to read your code or a computer to run your code. During this talk, we are assuming that code is primarily meant for human consumption. We are specifically talking about how easy it is for humans to read your code. Let's talk about how you structure your code. This basically boils down to where you put your line breaks. We are also going to talk about, during this talk, naming unnamed things and naming things descriptively. And finally, we're going to reconsider some of the programming idioms that we use every day. We'll be looking at a lot of small code examples. I'm going to tweet out the slides after this talk, so don't worry about missing any code that you don't understand. Let's talk about the structure of our code first. In the modern age, line length is no longer a technical limitation. Screens are really wide. Line length nowadays is about readability. Long lines are simply hard to read. Line length is a little flawed, though. Line length only approximately correlates with readability. When discussing line length, remember that short lines are not the end goal. Readability is. So when inserting line breaks, make sure that you're focusing on readability, not on line lengths. Let's take a look at an example. This code has a line length under 60 characters. As you read this code, you're probably trying to figure out what it does. You're not going to figure out what it does until you've discovered the structure of this code. That first line there, it is a generator expression that has two for loops inside it. That second line is a generator expression that has an if statement inside it and a single for loop. This code is hard to read because the line breaks were inserted completely arbitrarily. The author of this code was focusing on line length and not on readability. Is this code more readable? Yeah. This is the same code as before, but the line breaks have been moved around to split up the code into logical parts. These line breaks are not inserted arbitrarily, they were inserted with purpose. The purpose of improving readability. Let's talk about regular expressions. This function returns true if the string it is given is a valid universally unique identifier, a UUID. UUIDs consist of a bunch of hexadecimal digits with dashes in between them. This function uses a regular expression. It's split over 2 lines of code here. It could have been 1 line of code. It's difficult to read because regular expressions are information dense. Regular expressions are code. It's a programming language inside of a programming language. Regular expressions are code written all on 1 line without white space or comments. Who writes their Python code all on 1 line without white space or comments? All right, I don't see any hands, so there's not even any jokers in the room. No one writes their Python code on one line without white space or comments. It's not possible to do. You wouldn't write your Python code this way. You couldn't write your Python code this way. Why do we write our regular expressions this way? When using regular expressions, always enable verbose mode. Verbose mode allows you to wrap your regular expressions over multiple lines and insert comments. We've broken up what we had as 2 lines of code into 13 lines of code. We've also added white space, and we've added comments. Those extra line breaks are the biggest help here, though. When using regular expressions, always turn on verbose mode. Let's look at another example. Let's say we are creating a Django model, and one of our model fields has a bunch of arguments being passed to it. So we are passing a lot of arguments into this foreign key field. If you don't understand Django, this is a function call, or maybe a class that's being called here. This feels a little bit unwieldy. There's a lot of things going on here. Is this a good way to wrap our code over multiple lines? What about this way? Is this better or is this worse than what we had before? How about this one? How does this compare to the other two? Would anything change here if we were exclusively using keyword arguments? Would that affect our choice? So personally, I usually prefer that last strategy for wrapping my lines, especially with all keyword arguments. That first one is difficult to read, and the second one is tricky when you've got really long lines like we do here. Let's take a look at that last strategy more closely. Would it be better to leave the closing parenthesis on its own line? What if we added a trailing comma? Would that make things better or worse? So personally, I prefer this one the most when I'm calling a function or a class on its own, but not when I'm defining a function. Now, I am certain that many of you disagree with my preferences here, and that's okay. The fact that we disagree means that we must document the way that we wrap our lines using a style guide for every project we create. You do have a style guide for every project you create, right? Consistency lies at the heart of readability. Make sure you define a style guide with explicit conventions in every single Python project you make. Speaking of style guides, let's talk about PEP8. So PEP8 is the Python style guide. If you aren't familiar with PEP8, read it. If you think you're familiar with PEP8, reread it. In fact, why not make a habit of rereading PEP8 every 6 months and thinking about how your perception of it has changed and your relationship with your code has changed. So PEP8 is the Python style guide, but it is not your project's style guide. You need an opinionated style guide. PEP8 is not opinionated enough for your project. It's a great starting point, though. You need a style guide that goes beyond PEP8. Do poets use a maximum line length to wrap their lines? No. Poets break up their lines with purpose. In poetry, inserting a line break is an art form. In code, inserting a line break is also an art form. So as programmers, we should wrap our lines with great care. And remember, all of your projects should have a style guide that goes beyond PEP8. Your code style conventions should be explicitly documented. If a concept is important, it needs a name. It deserves a name. Names give you something to communicate about. Unfortunately, naming things is hard. Naming a thing requires describing that thing, and describing things isn't always easy. Not only that, once you've described a thing, you need to shorten that name or shorten that description into a name, and that's not always easy either. If you can't think of a good short name, use a long and descriptive one. That's a lot better than a subpar name. Plus, you can always shorten a long name tomorrow. So when naming things, worry about accuracy of your variable names and not the length of them. Let's take a look at a couple code examples with poor variable names. I bet you do not know what SC stands for in this code. You might know if you had more context, but if you're new to this code, you'll search around for a while until you may finally discover that SC stands for state capitals. Don't use two-letter variable names in Python. Use descriptive names. Speaking of descriptive names, what does this variable I here represent? Is it a two-tuple? Is I sub 0 capitals, or is it states, or is it something else completely? Whenever you see an index access like that sub 0 there, those brackets with a number in it, this should be a red flag. Index accesses can usually be replaced by variables. To do this, we can use tuple unpacking. You can probably tell now that S means state and C means capital. So avoid using arbitrary indexes. And when possible, use tuple unpacking instead. It's often a lot more explicit to use tuple unpacking rather than having these arbitrary indexes in your code. Now, while you did probably guess that S and C here mean state and capital, there's no reason not to use real words for these variables. Name every variable with care. Optimize for maximum accuracy and completeness, not for short variable names. Let's take a look at an example of code that could use some more variable names. This code returns a list of all anagrams of this word variable here. All anagrams of this word variable that are specifically in the candidates list that comes into this function. This isn't bad code, but it's also not the most descriptive code. That if statement in particular is pretty long. What if we abstracted that logic out into its own function? So we have an isAnagram function we're calling now. I think that makes things a lot more obvious. We are checking whether two words are in fact anagrams. We've broken the problem down and described the process that we're using, and at the same time, we've hidden away the details of our actual algorithm in that function. Let's take a look at that isAnagram function. So this is pretty much exactly what our if statement had in it before. It could still use some work here, though. Word1.upper appears twice, and so does word2.upper. So we have a little bit of code duplication going on. Let's fix that. So I think that's a lot better. I find the conditional expression on that last line a little easier to read at this point. I think there's still room for improvement, though. So one strategy I like to use to test code clarity is to read my code aloud, to test how descriptive it is. So here we are sorting our words, checking whether the sorted versions are equal, and then checking whether the unsorted versions are not equal. That description is not very helpful. That's not how we describe asking or checking if two words are anagrams in English. Let's write a comment that describes our intent a little bit better. So we've added two comments here. If we ignore the code and just read the comments, we'll see that we're verifying that the words have the same letters and whether they are different words. Whenever you find yourself adding a comment to your code, that might be a hint that you need to make another variable name. Remember that comments describe things, and variables make that description into code. So let's turn those comments into some descriptive variable names. So we've turned those two conditional statements into two new variables that describe what they do. That last line says that we are checking whether these words have the same letters but are different words. That's exactly what our comments said before this. These new variables are different letters and have same words, made the logic of our function a little bit more explicit. This code is more clear and more readable because we are conveying the intent of our algorithm and not just the details. So we ended up adding, I think, 4 extra lines of code here. But we broke down our process a bit. So our code is a little bit easier to understand at a glance, especially for a new programmer, especially to someone who's new to this block of code. Now, you may think this is a silly example. I mean, what we started with was not really that complicated. But even if you decide to revert some or all of these changes, this was still a worthwhile mental exercise. The exercise of refactoring your code to make it more self-documenting and more readable can really reframe the way you think about your own code. Let's take a look at a complex Django model method. So this function is a method that lives inside of a Django model. There's a lot going on in this method. Instead of reading all this code, I want you to unfocus your eyes and look at the structure. Let me help you out. There. So now we can talk about this code without you getting distracted and reading it as I'm speaking. The first thing you'll notice is that this code is broken up into 3 sections. This code was broken up into 3 sections because each of those sections performs a different task. Let's add some comments to these sections to see what they do. In my opinion, adding those comments improves the readability of this code, not just because the code is blurred out. We can understand very quickly what each section is actually doing here by simply reading the comment. Depending on why you're reading this code, you might even be able to get away with only reading the comments, which is great. You can understand what the code is doing without needing to understand all of the details. But sometimes comments are a hint that we might have forgotten to name some things. We have comments that describe each of these sections of code. We could also name them. Let's turn these comments into variable names by putting each of these blocks of code into its own method. So we've named each of these 3 sections of code by making 3 separate functions. These functions are methods that live next to our original code. They're helper functions of sorts. We left the comments in as documentation strings because it never hurts to have extra clarity through documentation. So now that we've made 3 separate methods for each of these sections of code, we need to call these in our original method. Now, I don't know about you, but I find this a lot easier to digest than the 3 completely undocumented blocks of code that we had before. We've named the 3 actions that we're doing. And most of the time, you probably don't have to worry about the details of each of these 3 actions. These variable names are good enough. So let's do a brief recap. Read your code aloud to ensure that you're describing the intent of your algorithm in detail. Remember that comments are great for describing things, but sometimes a comment is just the first step toward a better variable name or toward a missing variable name. Make sure you give a name to everything you can, and in general, strive for descriptive and self-documenting code. Let's talk about some of the code constructs that we use. There's usually multiple ways to write the same code, but there's often multiple tools that we could use to write that code. So when given the opportunity, in general, I prefer to use specific purpose tools over general purpose tools, as long as they are easy to understand or easier to understand. Specific problems call for specific solutions. Let's take a look at some exception handling code. Here we are opening a database connection. We are reading from that database connection, and then we are closing that database connection. We need to make sure that we close our database connection even if an exception occurs, so we're using a try finally block here. Whenever you have a section of code that's wrapped in a try finally or has some kind of cleanup step, I want you to think about using a context manager instead. It's not that hard to make your own context managers. To do so, you need to make a dunder enter method and a dunder exit method. Oh, and for those who don't know what dunder stands for, it stands for double underscore, because there are 2 underscores before the method name, 2 underscores after that name. Let's take a look at how we can use this context manager we've made here to refactor that code. So this is somewhat simpler than that try finally statement that we were using before. As a reader of this code, we don't have to worry about whether we're closing the database connection after we open it. That's pretty nice. But we don't always have to write our own context managers like we just did. The standard library has a closing context manager. It does pretty much the same thing as what we were doing. So whenever you need a cleanup step, think about using a context manager. and you can probably find one that fits your use case in the standard library or a third-party library. You rarely have to write your own. Let's talk about for loops. This code loops over something. You can tell that even though it's blurred out. This code actually does a little bit more than that, though. Specifically, the purpose of this code is to loop over something, check a condition, and create a new list from items that pass that condition. We're using a list append, an if statement, and a for loop to accomplish this task. There's a better way to write this code. Here we are accomplishing the same task as before, but instead of using a for loop, an if statement, and an append call, we're using a list comprehension. This code is shorter, but it does contain less unnecessary information for our brains to process. Actually, it isn't shorter. It's one line longer, I think, than what we had. So when we glance at this code, we don't think looping. That's the important part here. Looping is not what we're thinking about. We think we are transforming one list into another list. That's a better description of what our code actually does. When you have a specific problem, use a specific tool. Let's say we're creating a class to represent items in a shopping cart. This shopping cart class is a wrapper around a dictionary. Now, the code is not included in this class. You can guess what the code is from the documentation strings. I had to fit it on a slide. Notice that this class here implements a lot of methods that really just access that dictionary that we are using under the hood in a fancy way. These methods check for containment, they add things, they remove things, they ask questions about the status of our shopping cart, how many things are in it, whether or not it's empty. These methods should seem a little bit familiar. All of these methods correspond to operations that work automatically on many native Python objects, like dictionaries and lists. When we use custom methods and properties, someone trying to use our class will need to learn those custom methods and properties before they can use it. If we use built-in Python operators instead, the users of our class will not need to worry as much about learning new things because they already probably understand how lists and dictionaries work. In terms of details of how we could do that, how we could make our own list or dictionary-like object, we could use those dunder methods again. We can make the operators under the hood work on our class using dunder methods for operator overloading. So with this change here, our shopping cart will feel a little bit more like a native Python object. We can check for containment, we can set items, delete items, check the length, and check whether our shopping cart is empty. Do not be afraid of reaching for operator overloading when it makes sense. By the way, the standard library has abstract base classes that make this even easier. If you're ever planning to make your own container-like object, a list, a dictionary-like object, or something similar, check the collections library first. Let's talk about functions. This code connects to an IMAP server and reads email. Notice that one of these functions returns a server object, and the other three functions each accept a server object. This should be a hint that something weird is going on. If you ever find yourself repeatedly passing the same data to multiple functions, think about making a class. That is exactly what classes were designed for. Classes bundle together functionality and data. Okay, let's do a recap. When you find yourself wrapping code in redundant try finally or try except blocks, think about whether you could use a context manager instead. When making one list from another list, use a list comprehension. When your object looks like a container and acts like a container, use operator overloading and make it into a container. Don't be afraid of dunder methods. If you have a specific problem, use a specific solution. When you're writing code, stop to pause every once in a while and actively consider the readability of your code. You can use this checklist here as a starting point to make your own reflections on code readability a little bit easier. As you use this checklist on your code, start to build up that code style guide that we talked about earlier, that we all agreed we need to have in our own projects. Remember that every project you make needs a detailed code style guide. The more decisions you can offload to your style guide, the more brain power you'll have to worry about less trivial and more interesting things. This is a link to my style guide. This is not your style guide. You need to make your own style guide. You are welcome to look at mine. You can steal it if you like. Make sure that you make one that matches your own code style, though. And finally, here's a list of videos that I recommend watching when you get home. Specifically, that first one, I said you should make classes when you have functionality and data that you want to bundle together. If you do not have functionality and data that you want to bundle together, don't make classes. Please watch all these videos. They're really great. I would like to take questions in the hallway so we can talk a little bit more in person. Thank you. As you read this code, you're probably trying to figure out what it does. You're not going to figure out what it does until you've discovered the structure of this code. That first line there, it is a generator expression that has 2 for loops inside it. That second line is a generator expression that has an if statement inside it and a single for loop. This code is hard to read because the line breaks were inserted completely arbitrarily. The author of this code was focusing on line length and not on readability. Is this code more readable? Yeah. This is the same code as before, but the line breaks have been moved around to split up the code into logical parts. These line breaks are not inserted arbitrarily, they were inserted with purpose. The purpose of improving readability. Let's talk about regular expressions. This function returns true if the string it is given descriptively. And finally, we're going to reconsider some of the programming idioms that we use every day. We'll be looking at a lot of small code examples. I'm going to tweet out the slides after this talk, so don't worry about missing any code that you don't understand. Let's talk about the structure of our code first. In the modern age, line length is no longer a technical limitation. Screens are really wide. Line length nowadays is about readability. Long lines are simply hard to read. Line length is a little flawed, though. Line length only approximately correlates with readability. When discussing line length, remember that short lines are not the end goal. Readability is. So when inserting line breaks, make sure that you're focusing on readability, not on line lengths. Let's take a look at an example. This code has a line length under 60 characters. Requisite for maintainability. You can't maintain code unless you can read it. Also, not all teams are immortal. You do sometimes need to hire new developers. When you hire new developers, you need to onboard those new developers. It is a lot easier to onboard a new team member if they can read your code. Before we get started, let's make it clear what we are not talking about. We are not going to talk about how easy it is to write code. We are also not going to talk about how easy it is for a computer to read your code or a computer to run your code. During this talk, we are assuming that code is primarily meant for human consumption. We are specifically talking about how easy it is for humans to read your code. Let's talk about how you structure your code. This basically boils down to where you put your line breaks. We are also going to talk about, during this talk, naming unnamed things and naming things
Good morning. We've got Trey Hunner here, and he's going to talk to us about readability. Thank you, Trey.
Thanks, Jim. Hi, so I don't have an introduction slide, so you can look stuff up about me on the internet. Feel free to ask me afterwards. So we are going to talk about readability. Readability is simply the measure of how easily we can read our code. We're talking about code here. This is a definition about text from Wikipedia. It's the same deal. So we are all here because we care about readability, or because you stayed in this room from the last talk. For those of you who care about readability, why do we care about readability? What makes readability important? Every time you fix a bug, change some functionality, or add a feature to your code, you probably need to read your code. So you probably read more code more often than you write it. Also, code doesn't always completely stagnate. You do sometimes need to change code. To change code, you need to read that code. Readability is a prerequisite